Hey guys, welcome to the ML show. And in this video, we're going to introduce artificial intelligence. So, what is artificial intelligence? Well, it is the simulation of human intelligence by machines. Now, what do I mean by human intelligence? Well, human intelligence is the human's ability to infer from data, recognize patterns, and make decisions based on our previous experiences and knowledge. And to do this, a machine creates what is known as a model or an algorithm, which is trying to simulate human intelligence. So, as we know that there is artificial intelligence, which is like an umbrella term, then there is machine learning, which is a subset of artificial intelligence that enables these computers to learn. And you will see a lot of time artificial intelligence or AI is mixed with machine learning or ML. And this is done very commonly because they are very similar terms, but in essence, machine learning is a subset of artificial intelligence. Now, a specific type of machine learning that has gained a lot of traction in the news is deep learning. And it is a specific type of machine learning that involves neural networks. And we'll learn more about deep learning and neural networks in a future video. But for right now, all you need to remember is that artificial intelligence is the umbrella term. Then there is machine learning, which is a subset of artificial intelligence. And then there is deep learning, which is a type of machine learning which has enabled powerful tools such as ChatGPT or DALI AI or Midjourney. So a machine learning problem can be classified into two categories. The first is classification, which is where we have two or more categories and we need to predict which category does this piece of data fall into. So for example, let's say our two categories are a dog and a cat. And the model's job, which is simulating the human intelligence, is to categorize that picture into either the dog or into the cat category. And if you have if you have two categories or classes, it's called a binary classification problem. And if it is more than two classes, like let's say we have bicycle, dog, cat, human, guitar, TV, then it's a multi-class classification problem. The second type of problem in machine learning is prediction, where we are trying to predict a value that we have not seen previously. So this could be, for example, we're feeding our model data of the price of the stock market for the past 20 years. And it's going to learn from the data, and its job is to predict tomorrow's price in the stock market. And this is prediction. We are trying to predict a value that is not in the data set. So what are some of the applications of artificial intelligence? Well, firstly, there's spam filtering. So let's say in our Gmail, you may have seen that there is a spam box. And what it is essentially doing is that it has some kind of machine learning algorithm or model which is running in the background, which is going through all the emails that you're receiving. And the model needs to classify that list of emails, each email as either spam or not spam. And so this is a binary classification problem where the model is categorizing the emails into spam or not spam. Now the second type is mobile banking, where the model is sent to identify fraudulent transactions. So the model is fed a list of transactions that are done, say, on one day, and its job is to identify whether this transaction is fraudulent or not. And this is again an example of binary classification problem. Another example is the stock market. So like we discussed previously, we can give a model the past 20 years of data of a stock market, and we can ask it to predict the value of tomorrow's prices. And this is a And this is a example of the prediction problem. Then there is social networks, and this is a very popular example, and it is something that has affected all of us, whether we know it or not. And so, what social platforms do is that they run a model, and let's say we take Instagram as an example. So, Instagram has a so Meta, which is the uh, parent company of Instagram, is has a model which is running, and to that model is fed all the reels that you have liked, all the posts that you have liked, what kind of friends you're with, and other information that that company has about you. It feeds all of this data into a model, and that model is trying to predict which reel or which post will you like. So this is a prediction problem, and this is used by almost all social platforms. YouTube uses this to recommend you videos. Twitter or X nowadays is uses this to serve you with the posts that it thinks will be the best for you, which will be the most engaging for you. And so this is a very popular example of machine learning. And there are other uses as well that you will learn as you delve deeper into this topic. So, what are the steps to creating a model? Well, first, we need to identify data. So, just like humans, a AI model, artificial intelligence model, needs some data to work with. So, if we take the example of humans, when we were born, right, we didn't know how to solve, let's say, an algebraic equation. But we built up a foundation. We first learned addition, then subtraction, then multiplication, then division, then fractions, then decimal points. And this becomes our data set. This is all the data. This is the foundation. This is the data that we have been trained on, the humans. And now we are able to solve these algebraic equations based on all of this data. So just like that, for an AI model to learn, to solve these problems, it needs some data. Then the second step is to choose an algorithm. And in this, we can either create an algorithm from scratch, or we can find an optimal algorithm, which we may think will be best suited for this problem. And so this step requires a lot of experimentation because there is no set in stone rule for which algorithm or which model will be the best for which problem. Then the third step is to train the model. So we take the data that we have identified in the first step and the model that we have created or found in the second step, and we feed that data into the model, and the model is trying to deduce patterns and learn from the data that is being fed. So, for example, a if we have a classification problem of whether it's a human or not a human, and this can be used, for example, in self-driving cars. But now these models are a little bit more complex. But just to simplify this, let's say we have humans and not humans, and so this model uh, may identify that. Okay, so the data which we know is human, has some features such as ears, eyes, hair, which other which the data which is not classified as human does not have. And so this algorithm learns that patterns. And then the fourth step is to analyze the model. So we look at the previous three steps and we look at some statistics provided to us by the model, and we look at, okay, how well did it perform? How well was the accuracy? How well was the model able to predict whether the image was a human or not a human? And this is a cycle essentially, because it is very, very unlikely that on the first try, your model is going to be the best one. You're going to get 100% accuracy or 99% accuracy. It's almost impossible. And so this is a cycle where we analyze the model, we look at where it's failing or where it can be improved. Then we go back to identify the data. Do we need to add more data? Do we need to remove more data? Do we need to change the data? Then we go again to the choosing algorithm. Can we change something in the algorithm to make it more optimal, more efficient? And then we look at the training model, the third step. We look at, okay, these are the parameters that we fed the model. Do we need to tweak them? Do we need to change them slightly to get better performance? And so once this cycle is done, we are ready to deploy the model. And to deploy the model, there are two categories that we can do. The first is on cloud. And this means that we upload our model to a server. That server can be your laptop, an old laptop that you have lying around, or the laptop you use every day, or a server or a computer on which is owned by companies such as Google and AWS or Amazon Web Services, and we are paying them to host or to store that model on their servers. And whenever we want to access that model, we are able to access it. The second type is on device, where we are uploading the model to the device of the user. So this is, for example, done by Apple. Apple will upload their, for example, predictive text model onto your iPhones, your iPads, your laptops, so that they're accessible when even when your devices are offline. And another plus point of doing it on device is that you get to uh, keep your users' data safe because it's not leaving the device. It is all the computation that is happening on device. And so this is pretty much it. Thank you for watching this video. I hope you were able to understand uh, this topic. And if you have any questions, please leave it down in the comment section below.